Welcome back for the 10th session of the geometrical properties of section in engineering mechanics and strength of materials. Here we are going to solve some problems related to the moment of inertia like I section and C section. In the first problem, we are going to find out the moment of inertia of the section shown in figure about its centroidal axis, which is perpendicular to the web. Here in the given I section, the dimension of the bottom flange is 200 by 20 and the web is 20 by 100, which is given here, and the top flange width is 100 millimeter by 20 millimeter. To find out the center of gravity of the whole I section, we must divide the I section into three rectangular boxes, that is bottom flange as a one rectangle, web as another rectangle, the dimension is 20 by 100, and the top flange as another rectangle, that is a third one rectangle, 100 by 20. Before going to find out the centroidal distance, that is x bar and y bar, we must provide the reference axis. Here I am going to provide the x axis at the bottom of the I section and y axis at the center of the I section. This y axis is going to divide the I section into two equal half. Therefore, the distance which is related to the measurement of with respect to y axis is going to be 0. So which is x bar is going to be 0 because the I section is symmetrical about y axis. Because of the symmetry about y axis, we need to find out y bar distance. Therefore, to find out the center of gravity of the I section, we must go by each rectangle. So in the first rectangle, the area of the first rectangle is 200 by 20 millimeter and the area is 4000 millimeter square. So the centroidal distance with respect to the x-axis is half of the 20, that is 20 by 2, that is 10 millimeter, which is noted as y1. Now coming to the second rectangle. In this second rectangle, the dimension is 20 by 100, so that 20 by 100, the area is 2000 millimeter square, and the y2 distance is from the centroid to the reference axis is y2, that is half of the 100 plus 20, that is 20 plus 100 by 2, that is 70 millimeter. In a third rectangular box, the dimension of the rectangle is 100 by 20 millimeter, and here the centroid is, we have to measure from here to the reference axis. To measure, it's 20 plus 100 plus half of the 20, so 20 plus 100 plus 20 by 2, that is 130 millimeter. We have obtained the area and y distances. Therefore, we need to find out the y bar by using the formula area of the first rectangle, centroidal distance of the first rectangle, area of the second rectangle, centroidal distance of the second rectangle, plus area of the third rectangle, centroidal distance of the third rectangle, divided by area 1, area 2, area 3, individual rectangle area. So if we substitute here, we are going to find out the y bar as 55 millimeter. If we obtain the 55 millimeter, we need to mark it in I section. So if we go back here, from the base, we are going to mark the centroidal distance, that is y bar 55 millimeter. Let's go to the next slide. Here, next step is we need to find out the moment of inertia of the I section. To find out the moment of inertia, we must go by the moment of inertia of the individual rectangles. That is bottom flange, the moment of inertia of the rectangle. First, with respect to the x is BD cube by 12, the width is 200 millimeter and depth is 20 millimeter, divided by 12, it's 13.33. and this one is a y bar minus y1, that is the difference of centroidal distance of the whole section to the centroidal distance of the first section. It's 55 minus 10, 45 millimeter. In a second rectangle, that is web rectangle, moment of inertia of the second rectangle with respect to the x axis is BD cube by 12, that is width of the second rectangle is 20 millimeter by 100 millimeter. If we substitute 166.66 into 10 power 4 millimeter power 4. Here the centroidal distance of the second rectangle is y bar minus y2, 55 minus 70, that is minus 15 millimeter is the centroidal distance with respect to the section to the centroidal distance of the second rectangle. In the top flange rectangle, the moment of inertia of the third rectangle with respect to the x axis is BD cube by 12. The width of the top flange is 100 by depth is 20 millimeter. So if we substitute, we will get the value of 6.66 into 10 power 4 millimeter power 4. The centroidal distance of the whole section to the third rectangle is 55 minus 130, that is minus 75 millimeter. To find out the moment of inertia about centroidal x axis perpendicular to the web, the formula is moment of inertia for the x axis is equal to moment of inertia of the first rectangle with respect to x axis plus area of the first rectangle multiplied by the centroidal difference between the centroidal distance of the whole section to the first section square plus moment of inertia of the second section with respect to x axis plus area of the second rectangle multiplied by the centroidal difference of the whole section to the second rectangle square plus moment of inertia of the third section with respect to x axis plus area of the third rectangle multiplied by the centroidal distance of the whole section to the third rectangle square. If we substitute all the value of, then we will get the moment of inertia of the given section with respect to x axis is 22.266 into 10 power 6 millimeter power 4. So this is the moment of inertia of the given I section, which is symmetrical about y axis. Now let's go to second problem. In the second problem, we need to find out the moment of inertia of the given channel section about the centroidal y axis. Here in the given channel section, the dimension of the channel section at the bottom is 250 millimeter and the overall depth of the channel section is 550 plus 25 which is 600 millimeter, and here top width is also 250 millimeter. But in the top flange of the channel section it is 25 millimeter depth and bottom flange 25 millimeter, but in the web it is having 30 millimeter depth. To find out the center of gravity of the channel section, we must divide the channel section into 3 rectangular boxes. Let's divide the bottom flange as one rectangle. So the dimension of the first rectangle is 250 by 25 and the second rectangle is 30 by 550 and the third rectangle is 250 by 25. To find out the center of gravity, we must provide the reference axis. I am going to provide the y axis exactly vertical side of the channel section and x axis at the center of the channel section. And if we provide the x axis at the center, it will divide the channel section into 2 equal parts. Therefore, it is symmetrical about x axis with any distance which is measured with respect to the x axis is going to be 0. Therefore, it is symmetrical about x axis. Therefore, the y bar is going to be 0. To mark the center of gravity, we must need to find out the value of x bar. So let's find out the value of x bar by each rectangle If you consider the first rectangle, the area of the first rectangle is 250 by 25, that is 6250 millimeter square. The centroidal distance x1 is, with respect to the y axis, is 250 divided by 2, that is 125 millimeter. And in the second rectangle, the dimension of the second rectangle is 30 by 550, that is 16,500 millimeter square. And the centroidal distance with respect to the y axis for the second rectangle is x2, which is 30 by 2, and it is 15 millimeter. The area of the third rectangle is 250 by 25 millimeter depth, with the centroidal distance with respect to the y axis, that is x3, is 250 by 2, that is 125 millimeter. So we have obtained a1, a2, a3 and x1, x2, x3. We can easily find out x bar. To find out the x bar, the formula for x bar is area of the first rectangle, centroidal distance with respect to the x axis of the first rectangle, plus area of the second rectangle, centroidal distance of the second rectangle with respect to the x axis, area of the third rectangle, centroidal distance of the third rectangle with respect to the x axis, and the area 1, area 2, area 3. If we substitute all these values, we will get 62.41. We need to mark in the C section. Therefore, let's mark here, that is 62.43 from the y axis. So here we have marked the center of gravity of the C section. Let's find out the moment of inertia for the given channel section. We have to go by the each rectangle. To find out the moment of inertia of the first rectangle with respect to the y axis is dB cube by 12, where the depth of the section is 25 and the width of the section is 250. So 25 into 250 cube by 12, it's 32.55 into 10 power 6. To find out the centroidal difference between the first section and the whole section is 62.41 minus 125, it is minus 62.59. However, it is going to be square, so negative becomes square, so it is going to be plus. In a rectangle 2, moment of inertia of the second rectangle with respect to the y axis is dB cube by 12. The depth of the second section is 550 and the width of the second section is 30 millimeter. So 550 into 30 cube by 12, it's a 1.275 into 10 power 6 millimeter power 4. The centroidal distance of the whole section with respect to the second rectangle is 62.41 minus 15 is 47.41. In the rectangle 3, the moment of inertia of the third rectangle with respect to the y axis is dB cube by 12, which is 25 into 250 cube divided by 12. Therefore, 32.55 into 10 power 4 millimeter power 4 is a value. The centroidal distance of the third section with respect to the whole section is 62.41 minus 125, that is equal to minus 62.59. This negative indicates the centroidal distance which is behind the center of gravity of the whole section. Let's find out the moment of inertia about the centroidal y axis which is perpendicular to the web for the given channel section. So the formula for the given channel section, that is the moment of inertia with respect to the y axis, is nothing but moment of inertia of the first section, that is the rectangular section, with respect to y axis plus area of the first rectangle and centroidal difference of the first rectangle with respect to the whole section square. In the same manner for the second rectangle, moment of inertia of the second rectangle with respect to y axis and the area of the second rectangle, centroidal difference of the second rectangle with respect to the whole section square, plus moment of inertia of the third rectangle with respect to the y axis plus area of the third rectangle multiplied by the whole sectional centroidal distance. We have to deduct from third rectangle centroidal distance square. So if we substitute all these values, we will get the moment of inertia of the y axis, which is perpendicular to the web for the given channel section, is 152.39 into 10 power 6 millimeter power 4. So this is the end of the problems. Here we have given some multiple choice questions. Please go through this, it is available, and we have given answer to